Welcome to the second part of this lecture related to hash function. Today we'll do briefly two more applications of hash function. One is called message authentication and digital signature. All the message authentication we may be doing in detail later on, but since we are discussing hash function, it is appropriate to discuss two more applications here. As you can see, message authentication is achieved using the hash function itself, but it is something called, we have a keyed hash function here. That is, we will use a secret key in addition to hash function. Somewhat we have already done in previous lecture. Okay, that is somewhat message authentication. And when we use hash function along with the secret key, then this is called message authentication code, or in short MAC. Okay, message authentication code. We should remember this. We may call it MAC. MAC has several abbreviations. MAC is an abbreviated version of several entities in communication. Multiple access channel. Similarly, we have MAC in the data link layer, and so here it is message authentication code in cryptography. So now I have regenerated the figure. If you recall previous video, you have seen this figure there. See what is MAC all about. You have a message M here, and then what you do is you find the hash of this message M, h of M, hash function. Whatever you get there, a hash value, you encrypt that using the key. The secret key is shared between the source and destination. Then encrypted hash with the key is concatenated with the message. So M concatenation with encrypted hash with secret key. This is transmitted. Okay, and you know that how we use hash. We first preamble the main data, then at the end we have padded the hash quantity here, which is actually encrypted here. Now the destination would need, first of all, the legitimate receiver knows that I have to find the hash of the upper quantity, and whatever is here I have to decrypt it because it is encrypted. So when it will decrypt, because it knows the secret key, suppose it is DES, then whatever it will get will compare. What can hacker do? Hacker may change the message, but hacker cannot. Now what will hacker do? Hacker will change the message, then will find the hash of M, but hacker does not know the key. So hence hacker cannot encrypt this hash with key. So what will happen is hacker will embed this M here and h of M here. But destination knows that this second part I have to first decrypt using key. When it will decrypt, it will not get h of M same. So it will declare that something has altered. This is simple message authentication code. Detailed we will do in the separate topic on message authentication code, how actually it's achieved. Now comes the digital signature. See, market the main difference between message authentication code and digital signature is, in message authentication code we use symmetric cryptographic codes like AES, DES. Okay, that is the same keys being used at the encryption and decryption. Whereas in digital signature we use public key cryptography. That is, we will have a private key and public key pair. So you can see PR is the private key and PU is the public key. Okay, now what we will do in digital signature, we have a message M. We find the hash of this message M, h of M. Then we encrypt it using private key. That is very important. Yeah, for example, we depend on the PRA. And at decryption level, we will use public key. Now, what will be benefit of that? Suppose hacker wants to alter the data. Okay, alter your signature, alter the message. For that, hacker needs to know the private key, and private key, is known only to the party, only to the user who has generated it. Whereas public key anyone can use. Now see this. So the digital signature verification can be done even by hacker. We actually want to verify whose data is this, right? So what will happen is like this. Let me show it here. So you have a message M, you produce the hash of message, correct? Then you encrypt this using suppose RSA algorithm, and you have the private key, fine, and then this is what you embed. So you have M, you embed this part here. Okay, now let's go to destination. What will destination do? Destination will decrypt this part using public key, and this will give you back h of M. And also destination will compute the hash of M and compare. If they are same, it means two things. One, the data has not been altered, and also since you are using the public key of user A, it means this data is actually from user A, because private key is only available with user A. So that is why we call it signature. Okay, it's a signature that this. Suppose if you use public key of user B, suppose you use PUB, you will not be able to decrypt it properly. You will not get H of M. Okay, when you will not get H of M, it means that this data is not from user A. Only user A, source A, only source A's data will be verified by using the public key of user A. That is the property of digital signature. One more important point. Suppose in addition to digital signature, you want the confidentiality, that not only that hacker should not be able to alter the signature, but also hacker should not be able to even read it at all, decode it at all. So what you can do at this point, after you concatenate, you can use symmetric encryption here. Symmetric encryption with some key K, which is known as destination also. Suppose you can use DES algorithm here, because DES is very easy to implement than AES. So you can use DES here and DES here, encryption. So what will happen is you can add confidentiality to this. Now the other applications of hash functions we will not do in detail, just I will state it here. The first application is called one-way password. So in simple words, what is done is that when you enter the password, it is not the password that is being compared or stored, it is the hash of password. Okay, so this provides an extra layer security. Suppose if you use now hash with some secret key, so the hacker will not come to know the password. So usual passwords can be hacked by brute force method. You can guess all the passwords. But now if you are basically comparing hash of password, then it adds to the complexity of password detection. So this is one thing used in operating system level. Another application is intrusion detection and virus detection. In a very simple word, suppose F is a file. So rather than storing F, you store the hash of this F. So later you can compare the hash value of F and ensure that whether the file has been modified by the virus or there has been some intrusion attack on the file or not. These are detailed discussion. There are detailed discussion about this. I'm just giving a brief overview. But what we will study in detail is message authentication codes and digital signature are same. The only thing is in message authentication codes, we will be using symmetric encryption like DES, AES, or RC4. Whereas in digital signature case, we'll be using public key cryptographic codes like RSA and Diffie-Hellman, which we haven't done yet, but that is also one public key cryptographic code. RSA is very famous, so we can use RSA for digital signature scheme, and that is actually what most of the ATMs also use. And the digital signature, which we actually we have a concept of digital signature in various international transactions where the physical signature is not possible. So these digital signatures are now becoming very common in that case. So I would like to keep this short, and next video will discuss about how actually hash functions, some of the examples we'll see how actually hash function or hash algorithm generates hash of a particular data block. Okay, thank you.